For 11, 12, and 13, they're sort of similar. For number 11, we just want to expand this, which is going to make it look like numbers 12 and 13. For 12 and 13, we want to condense, which will actually make them look like number 11. So it's sort of forwards and backwards, and this is one of the items that people usually really like about this chapter. When we're expanding, we are going to take each piece and sort of separate it. If they are being multiplied here, we will write plus in between, sort of like they have down here with this plus sign. If they are dividing, it will have a minus sign in the front. So like this one has a minus sign in the front. Any of the exponents will move in front, sort of like this 2 here is in front of the log 5 of x. So we will have a 2 in front of that item when we write it out. So I'm going to start by writing log base 4, and they will all have log base 4 of 6. That's the top. And I'm going to put plus log base 4 of x squared. That was on top, so that's why it's a plus. This is on the bottom, so we're going to put minus log base 4 again of y cubed. Now we're almost done, but we have to deal with our exponents. Any numbers that were in the exponents are going to be moved, and they will move in front of the log involving that piece. So it's going to be log base 4 of 6 plus 2 log base 4 of x minus 3 log base 4 of y, and that is the answer for number 11. It's expanded as much as it can go. On numbers 12 and 13, we're going to condense, so we're going to go backwards of what I just did. So for this one, any numbers in the front will need to become exponents. So those are going to move over here, and over here. And I'm going to rewrite it. Log base 5 of 9 to the 1/2 minus log base 5 of x squared plus log base 5 of y cubed. Now, anytime you have a power of a 1/2, that's just like saying that you want to do the square root of 9. If it was the power of 3, it would be, or power of 1/3 would be cube root of 9. So for this one, we want 9 to the power of 1/2, which is square root of 9, which is 3. So I'm going to rewrite that as 3 there. And I'm just rewriting the rest of it. Log y cubed. And now I'm going to condense. They're all log 5, so I'm going to start by writing log base 5. Now, anything that has a plus sign, like this is a positive, so the 3 is going to go on the top, and the y cubed will go on the top. But the minus is in front of this one with the x squared, so that part is going to go on the bottom. So we're going to have 3y cubed on top here, and then x squared on the bottom, and the log base 5 is out front of all of that. It's not on the top or anything. It's out front of this fraction. And then that's the answer for number 12. For number 13, it's sort of the same type of process. I'm going to locate my exponents, and I'm going to move them over where they belong. So the log base 5 is 27 to the 1/3 power. There, that piece. And then minus log base 5 x to the 1/4 power plus log base 5 of y squared. We're going to rewrite these into radical form here. So log base 5, and this would be the cube root of 27, minus log base 5, and this is the 4th root of x, and then this just stays how it was, log base 5 of y squared. Now, anything that you can simplify, you need to. So cube root of 27 is 3. So that's like saying log base 5 of 3 minus log base 5 of 4th root of x plus log base 5 of y squared. And now I'm going to condense it all. I'm going to say log base 5. 3 is positive portion of this expression. the y squared is on with a positive portion, and then the minus here has that fourth root of x. So that would need to go in the denominator. So we have log base 5 of 3y squared over the fourth root of x. And now we could end up having to deal with this because we don't normally leave radicals in the denominator, but we're just going to leave that for now the way that is and box it.